Okay. So they're the same what? The same shape, but different sizes. Okay? And so we looked at it with triangles, and as Bo was saying, the angles of my the three angles of my triangle were all the same with their corresponding angle, but then the sides had a scale factor. So a similar solid is basically the same thing. It's basically saying that we had a box, right? So we had a Kleenex box, and then we had a box that was basically the exact same shape, it was just bigger. Okay? That's all that we're going to look at again. So then they're going to look at and ask you, well, is the shape similar or congruent? What's the difference between similarity and congruency? If two things are congruent to each other, they are what? Exactly the same. Everything's the same, right? The angles are, the sides are, whatever. The volume, the surface area, and so on and so forth. Okay, so here's another thing to think about. If you think about circles, would you say all circles are congruent to each other? No, right? I could draw a really little circle and a ginormous circle, right? Are all circles similar to each other? Are all cubes similar to each other? Yes, right? Are all spheres similar to each other? Yes, right? Are they all congruent? No, not necessarily, right? So we're talking about spheres recently. So we're going to try to compare everything that we possibly can. So when you're talking about similar solids, to see if they are similar. We're going to do what Bo said, basically. We're going to find the scale factor. When we find the scale factor, what's the most important thing that we do then when we use that scale factor to make our comparisons? Perfect. So when we say find the scale factor, you need to use it in the same order all the time. So as Bo said, if he did the big triangle over the little triangle, he needs to make sure that he does that the whole way through. Okay? If you do the big sphere to the small sphere, you just have to make sure that you do that all the way through again. And when we say all the way through, when you're going to do this with figures instead of triangles, you can compare anything that you want. So with spheres, I could compare radii. With cylinders, I could compare heights. I can compare slant heights. It doesn't matter what I compare. I just want to find the scale factor of each one and make sure that it's always the big one to the small one. And again, if you want to do the small one to the big one, that's totally fine too. I just have to make sure that I keep all of them in the exact same order. So when you do this, you just have to make sure that you're using the same things and they're in the same order. So when we get into, let's say, a triangular prism, you just want to make sure that the piece of the triangular prism that you're using is the exact same piece that you're using in the bigger one to the smaller one, or whatever. Okay? You just have to be consistent. What else are we going to say? So, incongruent solids, all corresponding angles are still congruent. The corresponding edges are congruent. And then we talk about the areas and the volumes. Okay? So, when we talk about theorem 12.2 or 12.1, we go back and talk about the volume. When we did this originally, we started out with perimeters, right? when we had the scale factor of a triangle compared to the bigger triangle or vice versa, what was true about the perimeters? Did they have the same scale factor? Perimeters did, right? Whatever my scale factor is, I could use that directly with my perimeters because perimeter didn't have a label difference. What happened then when we went to areas? We squared them, right? And if we were talking about the actual area, we first had to take the square root of both of my areas or surface areas and then make my scale factor. So what do you think happens in volumes with the air or the volume of similar solids compared to the scale factor? Uncube it, right? Exactly right. So the theorem says if two solids are similar, with a scale factor of A to B, for instance. It doesn't matter what it is. So again, remember my scale factor could be written like this. It could be written as a fraction. It could be written as using the word 2. All right? The surface areas were the scale factor of A squared to B squared. And now the volumes have the scale factor of A cubed to B cubed. So essentially, what has to happen is you need to set up a ratio of the volumes. And as Kenzie said, we want to uncube it. So how do you uncube something? Well, how did we unsquare something? We took the square root. So what's the opposite of cubing something? The cube root, right? So we're going to set up a ratio of the volumes and take the cube root of each. Now, this is where, if you have your calculator, you need to get that out right now. That's what we're going to talk about right now. Go to math. So you're looking for either this button right here, a little radical sign with a little X in the corner, or some calculators might actually have it, where the 3's in what again I would call the armpit. Okay? So if you don't have it on your thing, you might have to go to math. Then put in your number. And that's the cube.
How do I keep the number?
If you keep a number,
Like this one.
use your up arrow. Now put a cube. All right, did everybody find it? So now you got to make sure that you understand how to do this. So let's all do the same number. Let's take the cube root of 80. So try putting that into your calculator. So again, I have to hit math, and then I can just hit 4, and then I hit 80, and I got 4.3. Everybody else? I just want you to make sure that you know how to use your calculator. So, basically now we're going to set up a ratio, and after we take this cube root of that ratio, meaning the top and the bottom, that should become our scale factor. So, after we do this step right here, this gives us the scale factor. And we're going to then use that scale factor, which they call A to B, in a proportion. And let's say A is the small one, B is the big one. then I'm going to put my radius of the small one to the radius of the big one. Now, obviously, when we make this second ratio, we're not going to have both of those numbers. So we'd have a scale factor here, and we'd have one or the other of those radii. And then we would use that proportion to find the other radius. Or we could, again, like I said, we could do it to heights, we could do it to slant heights, we can do it to anything that we want. And you can do it to any portion of that figure. Okay? So, let's check this out. Here's the first one. That's it for the note part of it. I think you should drive in reverse all day long. What do you think about that? Well, yeah, but you tried to do that anyway.
Yeah.
So the first one says, determine whether the pair of solids is similar, congruent, or neither. So obviously, if you looked at this right now, would you say that they're congruent? Remember, if they're congruent, everything has to be exactly the same. Are my heights exactly the same? Obviously not, right? One's the square root of 7 and the other one's 5 square root of 7 over 2. So we're definitely not similar, or definitely not congruent. So now we have to check out similarity. So how do I figure out similarity? I have to test the corresponding parts of those two pyramids and see if they have the same scale factor. Okay, so somebody with the calculator right now. You got somebody with the calculator do this side right here to this side right here. Punch that into your calculator. Somebody else do the height to the height. Somebody else do the bottom to the bottom. Who's my volunteers? So you're going to just set it up as a fraction. So you're going to, whoever's doing the heights would do this. You're going to punch in the square root of 7 divided by 5 square root of 7 over 2 into your calculator. This is going to give you a decimal. Okay? Then somebody else do the two sides here. Somebody else do the bottom sides. Everybody got one?
Yeah, but it does the whole thing.
Say it one more time.
It does the whole thing. Like it's all in square root.
Then hit your arrow key.
And then do I first hit L1,
Yeah. You got 0.7? Okay, so now, that's not right. So now put in parentheses when you start doing this. Anybody get something? What'd you get, Mondo? Oh, you didn't do anything? Anybody do that, this calculation right here? Anybody do this side? Come on, people. Help me out here.
You got 1.2.
Well, then we need to try again.
It's not right.
No.
Okay.
All right. So this is why you need to do this in your calculator right now, please. Because you got to understand how your calculator works. So everybody do that one then right there. Put the square root of 7 divided by, and this is where you probably have to use a bunch of parentheses. So I can write the square root of 7 divided by, and then I'm going to hit parentheses, and I'm going to put everything else in my parentheses. 5 square root of 7 divided by 2. And close out my second set of parentheses. You should get not 1.2. How much? 0.4. You need 0.4. So if you didn't get 0.4, raise your hand so we can help you out. If you already got 0.4, now go on to the next one. And try this side right over here. 2 square root of 3 over 5 square root of 3. Punch that one into your calculator. And then the last one is 2 square root of 5. You got 0.4 again. Perfect. Divided by 5 square root of 5. And I got 0.4 again. So if the first one that we all did was 0.4, you guys did the side angle one was 0.4, and I did the bottom one, which was 0.4. Are my shapes similar? Exactly right? So what I'm proving to you is that you need to check all 3 of them. So if you just would have done the heights, the red lines, and then the one slanted side, and you saw, well, they're both 0.4s, you cannot jump to the conclusion that the whole thing's similar. You have to do that third side. As many things as they give you, you have to test them out on all of those things. Meaning the sides, the edges, the heights, whatever it is. So if they would have only given you the heights in the one side, you do both of those, they're both 0.4, that's it, you proved it right. But because they gave you 3, you have to do all 3 of them. Does everybody understand what I'm saying there? So what would we say here? My answer would be what? They're similar, right? They're definitely not congruent. Everybody good with that and figure out your calculator? Okay? So again, right here, a little different. Now we have a cone. Are they congruent? We probably don't even have to do much math on this one. Is this similar? Is 6 to 6 the same ratio as 15 to 16? Well, 6 to 6 is easy, right? What's my ratio? 1. Is 15 to 16 equal to 1? So are they similar? Are they congruent? No. This one right here would be neither, right? Oh, cow, come on. So then they're just not. All right? That makes sense to everybody? So again, you can do it to any of the pieces. So here, obviously, if you look at the heights, I hope you can tell that 8 over 10 is 8/10, right? Is 12 over 15. If I reduce 12 over 15, what do I get? Just reduce it into a fraction. 3 over 5 is 3/5, or 0.6, the same as 8/10? No. So are they similar? No. Okay? So again, I'm not even going to jump to the radical ones unless I absolutely have to. I can look at this fraction right here to this fraction right here, and I can automatically know that that's not true. Now, if you don't want to turn them into fractions, turn them all to decimals by just punching them into your calculator, and then you'll get the same thing. So this one should have said neither, right? Okay. So now we look at the theorem one, 12-1. Okay. So here's my problem. 2 similar cones have a radii of 9 inches and 12 inches. What is the ratio of the volume of the smaller cone to the volume of the larger cone? So they're asking you for the ratio. But remember, the ratio of the volumes has to be a cubed over b cubed. So in our case right here, what I would do in this, when they give you a problem like this, I'm going to take my numbers that are given to me and they're both radii. I have to first make sure that they're both the same thing. If one's a radius and one's a diameter, then I have to turn them into the same thing. So the first thing that I'm going to do is make a fraction with those numbers, but I'm going to reduce. So what's 9/12 reduced to? 3/4, right? So 3/4 is actually my what? That's my scale factor. That's my scale factor of the radii, but it's also the true scale factor of the whole shape. But now they ask us, what is the ratio of the volumes? So what do I have to do to this to find the ratio of my volumes? I got to cube it. And I got to cube both the top and the bottom. So what's 3 cubed? Well, it's 4 cubed. 64. So what's my ratio? This right here is my ratio for the volumes. So I find my original scale factor and I just cube it, both pieces. Everybody understand what I'm saying there? So 27 over 64. Now the one that gets a little bit more complicated is this one. So now I have, I don't know, a softball to a baseball, I guess. I don't know. They say 2 softballs, but it doesn't make sense. So I guess you can have a smaller softball game for littler girls. Okay. Anyway, so here's my volumes. Now they want to figure out what the radius is of the larger one, or sorry, of the smaller one, I think. So I'm going to take my volumes and notice that they didn't apply the pi. So when I write my volume here, I'm going to write what they give me. But do I realistically have to write pi in both of these? No, because if I would put the pi on the top and the bottom, realistically, they're just going to what to each other? Cancel each other out. Okay, so this scale factor right here is the scale factor of my volumes. So what does that mean? That both of these numbers have to be done, or has to be done to both of those numbers to get back to my scale factor. I got to take the what? The cube root. So now, punch this in and try it out. The cube root of that number right there, and the cube root of that number right there. And then, after you find both of those, stick them into your calculator, or just write them as a new fraction. So what's the cube root of 9.15? 2.1. What's the cube root of the other one? 1 point what?
6.
Perfect. Okay. So everybody good with this? This one right here would be considered my bigger one, right? This is my smaller one. So now it says find the radius of the smaller softball if the radius of the larger one is about 1.9. So where does my 1.9 go in my proportion? On the top or the bottom of my second fraction? Because why? The big one's already on the top. So here's my proportion. So punch that into your calculator and find that missing spot. And what do we get? What is the radius of the smaller one? 1.4? I think that's what I got earlier too. So then you're just right back to making your own proportion. Okay? So again, this is my actual scale factor of the whole thing. This was my scale factor of my volumes. And then I always have to convert it into the regular scale factor and then use that in my proportion. Make sense? Now, the only thing that doesn't make sense to me is this shouldn't be here, I don't think. Would you agree with that? That radius shouldn't be cubic. If you have a cubic radius, that's kind of weird. All right? Didn't even need to see another one of those kind. So if they give you the volumes, you set them up in a ratio, but take the cube root of each of those numbers. That's huge. Okay? All right, that's it. So what's tomorrow? Tomorrow is a quiz.
When's the test?
The test will be Thursday. Quiz tomorrow, second quiz study, oh yes.
Hey, I will be back if not, I'll put it in the meeting.
Well, here's the other thing, I guess we could do, no, that ain't gonna help us either. I really don't wanna do it on Thursday because I'm assuming that's still mass, right?
They moved
Still
it
regular
back
mass,
Wednesday, didn't
right?
they?
When do we leave that? Or-
Why don't we do it Friday?
No, we're not taking the whole day off.
One thing, they up study.
Yeah, right. The first thing you would do is get on your phone and not do anything.
No, you give them a review assignment. Oh, that's a good idea.
No. So we'll just go with Thursday and then, see what happens.
Oh, no, this is Thursday?
Always-
Yeah.
Thursday.
I was going to, but.
So review is Wednesday?
I think you should do it Saturday. You don't have to.
You can come in the morning and take it. I think when we did that,
On what?
we had to come in the morning.
When did you have to come in the morning?
Basketball. You remember that?
Oh, yeah, when you guys